Hello students, welcome to this video, and in this video we are going to talk about some examples which will actually determine what is the maximal interval of existence. Okay, so let us start with the first example, an easy one. Yes, so example 1. Let's look at this problem. Let's say that of one dimensional problem, right? So let's say y prime of t is given by cosine square y here, and y at the point 0, let us say it is 0. Yes, now as you can see that a problem like this, yes, this is a non-linear problem. This is a non-linear problem, okay, which can be solved, using separation of variable, right? Yes, so of course this problem you can think of it in terms of Picard's existence and uniqueness, that there is a solution in minus epsilon epsilon, that is fine. But the thing is that is not very useful in this case, because we can actually solve this problem. Yes, so use separation of variable and solve this problem. So if you do that, then you can see it is basically secant square y dy equals to dt, right? And then you integrate both sides. That's what's going to happen. Therefore the solution which you are going to get, so you have to check this part, this is easy. The solution which you are going to get is given by yt equals to tan inverse t. Clear? Now this solution, see, initially by looking at the problem, we don't know what exactly is the interval of existence is. Clear? Okay, because all of this you see cosine square y is defined for all y, it's not a problem, right? And y at the point 0 is given to you. So initially, just by looking at the problem, we don't know that whether such a the thing is what should be the interval of existence. But by solving that, we saw that yt equals to tan inverse of t, and these, you see, for any t between minus infinity and infinity, this is defined, right? So you see that, note that the solution y of t, okay, converges to plus minus pi by 2 as t converges to plus minus infinity, right? That is there. Yes, and then what happens is, you can see that, and in the middle everywhere it is defined. So essentially the maximum interval of existence, let's just put it this way, MIE, in this case is minus infinity, or the whole of R. Yeah, okay, right. So this is for a 1x1 system, which is basically just ODE, so it's simple ODE, right? Let's look at example where it is not a simple ODE anymore, but like a system, right? So let's look at this problem. Let's look at this system. X prime t equals to x, and y prime t is given by 2y. This is also a very simple system, but it's nonetheless, this is the system, right? Yes, and the initial condition which we have is x at the point 0, y at the point 0. The initial condition which we have is 1 and 1 here. Now, of course, we chose it in such a way that it's very easy to solve, right? So the above system solution is given by the above system admits a unique solution. Of course, it has to be a unique solution, admits an unique solution. How do you know that the solution is unique? You can use Picard existence uniqueness here. It is absolutely not a problem, right? So xt and yt. And anyways, you do not even have to do that. This is basically a linear system, right? You know that the solution is going to be what? It's a linear system, right? See, if you want to write it properly, this is nothing but x and y prime equals to 1, 0, 0, 2 times x, y, and the data at the point 0 at t equals to 0 is 1, 1, right? So you remember the fundamental existence theorem for the linear system. It says that there is a solution, right? And the solution exists, if you remember, for all t You do not have to use Picard here. Without Picard also you can say that, yes. But here you can see that so we can use this theorem there. But anyways, you can also solve this problem, right? And you can say that this is the solution, e to the power t, e to the power 2t, and this solution is of course valid for t between minus infinity and infinity. Clear? So in this case, and of course you can see that as t tends to, let's say, as t tends to infinity, okay, xt yt, the solution, that is here, blows up, okay, but converges to 0 0 as t tends to minus infinity. Yes, this is a very simple observation. Okay, so the thing is, but still it is always true that the maximum interval of existence for this system is again minus infinity to infinity or the whole of R. Is this okay? Right? So what I, first of all, by these two examples, what I meant to tell you is this: it may happen that the maximum interval of existence can be whole of R. Okay, it doesn't have to be bounded. Yes, it can be infinite also. These are the two examples, and there are like million other examples you can construct. It's not a problem. Clear? Okay. So another example, let's just see, and there are other situations also which can happen, right? Say example 3. So let's look at this problem. Let's look at x prime equals to f of x here, where f of x is given by f of x1, x2, x3, right? Because x is a vector field, right? And then that is nothing but x2 by x3 square, x1 by x3 square, and 1. So this is your the vector field f, right? And this is defined in where? Let's just look at the definition here. This is defined in R cross 0 infinity. See, x3 is between 0 and infinity, except 0. It is defined for all positive numbers. So basically it is between 0 and infinity, and the first two coordinates are defined in whole of R and R. Okay. Now let us look at this initial data, this initial value problem along with this initial data. What is the initial data? X at the point 1 by pi, clear, is nothing but 0, -1 and 1 by pi. This is the data given to us. So that's your problem. Clear? Now it is not very difficult to see that, you see, first of all, can you solve this problem? Yes, I am not going to solve this problem. What I am going to do is I am going to tell you how to solve this problem. So this is very easy, right? You see, x1 prime is nothing but x2 by x3 square, and again x2 prime is nothing but x1 by x3 square, and x3 prime is nothing but, you see, x3. Clear? So from here you can actually calculate what x3 prime is, right? It is some constant times e power t. Now you put these values here, and then you try to solve this problem, right? Then it's basically a linear system. Yes, of course it's a non-autonomous linear system, but it's a linear system which actually can be solved. It's not a very difficult thing to look at that problem. Okay, so please do that part. But anyways, I'm going to write down the solution. Okay, so the above system admits a unique solution, okay, and what is the unique solution? It is given by x1 of t, x2 of t, x3 of t, which is sine 1 by t, cosine 1 by t, and t. Okay, and this is for t between 0 and infinity. Yes. Okay, one small mistake I did. You see here f of with respect to x3, the third coordinate is 1, so this has to be, sorry, this is 1, right? So x prime t is 1, so this coordinate, the solution x3 of t is going to be t. Okay, Now you just put that value. Sorry, I just made small mistake. So this is there. Now you see this particular problem. Yes, this problem here for this problem to work, right, t has to be between, see, for this solution to work, t has to be between 0 and infinity. Yes, that is given, right? Because otherwise, if t is 0 and all, this sine and cosine there, this first coordinate and second coordinate are not does not exist, right? So note that as t tends to infinity, limit as t tends to infinity, sorry, t tends to 0 plus, that is 0 plus, x of t does not exist. So this is x of t, right? X of t does not exists. Clear? Okay. So it does not exist. So you have to have t between 0 and infinity, otherwise it does not exist. And we can actually show that, however, also the solution, you see, x1 square plus x2 square is always 1, right? Yes. So basically, for, let's say, if you fix t between, let's say, 0 and 1, okay, the solution is trapped in this cylinder, is trapped in this cylinder. What is this? x1 x2 such that x1 square plus x2 square equals to 1 cross 0 sum a positive. Here this is trapped in this. So you see, if you have when t is between 0 and a, clear? Yes. So the solution always is trapped in this region, right, in this cylinder, that is. Yes, and as t tends to 0 plus, the solution also another you see, the solution does not blow up. That's one important thing. Yes, it does not exist, but the solution also does not blow up. So basically it is trapped inside a bounded domain, right? So also limit t tends to 0 plus x of t does not blow up, that is not also, that is, right, it does not blow up. You see, as t tends to 0 plus, the solution always stays inside this cylinder, right? So it cannot blow up, but the thing is, it is not also defined. Yes. So the thing is, what I'm trying to say is this: here in this case, what is the maximum interval of existence? It is given by 0 infinity. Yes, the solution does not exist, so there is no question of blowing up, so it does not exist at that point. Clear? Okay, right. Now let's see that the most common situation what happens is generally speaking, for finding this maximum interval of existence, what we need to check is if the solution blows up or not. That is why we are just emphasizing on blowing up. So let's look at the fourth example. So example 4. So let's look at this problem. X prime t equals to 1 plus x square. Clear? And x0 equals to 0. Okay. Now you can easily see, you can easily check. See, this is, you use separation of variable. 1 plus x square equals to dt, right? And you integrate it. You can use separation of variable here. So you do it, and then you can easily see that admits an unique solution. Why unique? This again, you can use your Picard to prove that this is going to be unique. Xt equals to tan of t. Yes, and this t is between minus pi to pi. Clear? Yes. See, the solution which I am going to get is tan t, that we got. Yes, we did not get any other information, but we know that tan t is defined between minus pi to pi, right? We know that as limit t tends to plus minus pi by 2, what happens to tan t? That goes to infinity, right? The modulus of xt goes to infinity. Okay, so that will imply the solution, okay, solution cannot be extended extended, okay, for mod t greater than equal pi by 2. Okay, see, the thing is, maybe in some other interval it is valid, but the problem is this: I need to have, you see, the interval of existence must contain the initial data, right? And I am looking for a solution which solves the problem at x equals to 0, which should be 0 at x equals to 0. So this is the only interval which should contain this. Yes, so that is the maximum. You can extend it, you cannot do it anymore. So what is maximum interval of existence? In this case is minus pi by 2 to pi by 2. Is this okay? See, in any other interval also except pi by 2 you can leave it, and you can do it in another interval, tan will be defined there. But the problem is this, that interval will not contain 0, right? And I need, because we are looking for the problem at 0, a neighborhood of 0, that is. So this is the only interval which will work for us here, and that is the maximum which you can think of. So in this case, what is happening? The solution is blowing up. Okay, so infinity, solution blows up. This is the most important criteria, generally speaking, for finding most of the times maximum interval of existence. This is the criteria which we look for. Solutions blow up. Okay, so this side of situation also happens, but this is kind of rare. This is generally, I mean, we deal with this sort of situation. Okay, so let's look at a system. Let's look at a system, whether for a system also something like this happens or not. Okay, so let's look at this problem. X prime t equals to x plus 1 by y. Okay, and y prime t equals to y square. Clear? And what is the initial data? Sorry, what is the initial data? If the initial data is with x0 and y0 given by minus 1 and 1. Is it okay? Now you see, of course, this problem, if you write it down, if you f of x and y, if you write it, it is given by x plus 1 by y and y squared. Yes, so one can check that there is a solution, right? It's not absolutely, without solving anything we can do, we can just see that there is a solution. Yes, check that the problem admits a unique solution. Problem admits an unique solution. An unique solution. Okay, and what is the unique solution? In some, for some t between minus epsilon to epsilon positive. This is by Picard. Clear? Okay, but you see, we, of course, so by Picard, this is by Picard. Okay, but you see, in this case what happens is this equation is very, nice equation. So basically you can solve this equation individually without looking at x, right? So once you solve it, then you find what is the value of x. So clearly you see, y prime t equals to y square has a solution given by yt equals to 1 by 1 minus t. Why this I am choosing? Because I have to know y0 equals to 1. So basically we look at yt equals to 1 by 1 minus t. Clear? Once we do that, now hence if you put that value in our problem x prime t, so you see x prime t will look like this: x plus 1 by y is 1 minus t. Clear? And now if you just solve this problem, you can use integrating factor, right? You can just, this is just a how do I put it, a linear equation, right? This is a linear equation. So linear equation, yes, use integrating factor to solve it, and I am just writing out the solution, right? X of t, it will look like this: t minus 2 plus e to the power t. Yes, now you see, x of t looks like this. Y of t is 1 by 1 minus t. Of course, just by looking at y of t, we can say that t can only be between minus infinity and 1, right? It cannot touch 1, because once it touches 1, yt blows up, right? So t between minus infinity to 1 contains this 0 where we are looking at, okay, the initial data. So t between minus 1 and 1, yt is defined, xt will also be defined. X is defined everywhere, doesn't matter. Okay, but anyway, yt should not be defined. So hence you see, we cannot extend it for t greater than equal 1. So because see, So what is the maximum interval of existence in this case? It is given by minus infinity and 1. Okay, why? Because for t greater than equal 1, okay, limit t tends to, let's say, 1 minus y of t, this blows up, right? This blows up. Clear? So this is the maximum interval of existence. Is this okay? So this is how you most of the time for finding maximum interval of existence, to be very frank with you, if you can solve it, that's the best idea. Clear? Of course, Picard gives you some existence in some interval, but the thing is, it's not very precise. You don't know whether, you can't work with Picard, to be very frank with you, in most of the cases. What happens is, if you can solve it, so find a closed solution, an explicit solution, then you can just look at the solution and check whether in which side of intervals it is valid and what is the maximum you can actually approach. Okay, so this is how you calculate it, and with this we are going to end this video.